You update the model, you tweak the prompt, you add more system instructions, and yet your RAG system still gives you wrong answers. Most RAG systems don't fail at generation, they fail before the model even sees the right information. In this video, I will explain why RAG systems fail at retrieval, the four most common retrieval failure modes. Let's start with the biggest misunderstanding in RAG. We assume that the embedding similarity equals relevance. It doesn't. Embeddings answer a very specific question. Does this text sound semantically similar? But the user is asking a different question. Does this text contain the answer I need? Those two are not the same. A chunk can be highly similar and yet completely useless for answering the question. This single confusion is where most RAG pipelines quietly break. Let's talk about chunking, the most underestimated design decision in RAG. Most system chunk text using fixed token sizes, arbitrary boundaries, uniform overlap, and that destroys the meaning. Here's how. If you overchunk, you split the context across multiple chunks. Reference break, logic fragments. If you underchunk, you dilute the embedding. Important signals get buried inside the irrelevant text. The embedding doesn't represent the document, it represents that chunk. So if the chunk boundaries are wrong, retrieval is wrong, no matter how good the model is. Chunking is not preprocessing, it's retrieval design. Here's another hard truth. Most embedding models are not trained for your task. They are trained for general semantic similarity, not for answer extraction, factual lookup, procedural recall, latency sensitive queries. So what happens? You retrieve the chunk that sound related but don't actually answer the question. This is why people say the retrieval looks relevant, but the answer is still wrong. That's not a generation issue, that's an objective mismatch. Most RAG system picks a top K value once and never think about it again. Top 5, top 10, top 20, completely static. But top K controls the recall versus noise. Too small, you miss the answer. Too large, noise overwhelms the model. Here's the key insight. Top K is not a constant. It depends on the query ambiguity and the document density. A vague question needs higher recall. A precise question doesn't. Static top K silently breaks the retrieval and the model gets blamed for it. User asks short, compressed, ambiguous questions. Documents are verbose, structured, domain specific. This creates query document mismatch. The embedding model sees two very different distributions and tries to bridge them with a single vector. The result? Semantic drift, missed retrieval, irrelevant chunk ranking high. Most RAG systems embed the raw query once and hope for the best. Here's how most people picture RAG. Query goes to vector DB and then the fetched chunks goes to LLM. That's wrong. Real RAG looks like query understanding, query rewriting or expansion, high recall candidate retrieval, re-ranking for precision, context assembly, and then generation. If retrieval is weak, generation has no chance. Vector search is great for recall. It is terrible at precision. That's why re-ranking exists. Without it, you get low precision context, contradictory chunks, chronological inconsistencies. So model does what it always does when the context is weak. It fills the gap using internal knowledge. That is why we see hallucination. Generation failures are visible. Retrieval failures are silent. So when answer is wrong, we tweak prompts, temperature, models. But the real issue was upstream. The model hallucinated because the right chunk wasn't retrieved. Context was incomplete. Relevance was diluted. The model didn't fail, the system did. If you want better RAG answers, stop prompt engineering, the last step. Start fixing the system that decides what model is allowed to see. In the next video, I'll go deep into re-ranking, when it is actually helping and when it is just extra latency.